Hi there, it's good to see you again. What we're going to do is take this system, 2x minus 3y equals 2 and x plus 7y equals 52. We're going to use Gaussian elimination to solve. So remember, the Gaussian elimination involves using an augmented matrix. So I'm going to write the augmented matrix off to the side here. Remember, the augmented matrix just has the coefficients. So the first row is going to have a 2, a negative 3, followed by this vertical line here, and then a 2. And that's to show that 2x minus 3y equals 2. And then the second row will be 1, 7, 52. Now remember, with Gaussian elimination, the goal is to make the matrix look like this. So A, B, and C really have no restrictions. The main idea is that we have ones on the main diagonal on the left-hand side, and then a 0 in the lower left-hand corner, and then the other 3 are just numbers. And then with that form, we're able to go back to the equations and solve the system quite easily. So noticing that I need the 1 in the upper left-hand corner, now I have two options here. I could multiply the first equation by a half, or I could just interchange the rows, and interchanging the rows seems to be the better option here. So the notation for that is, now if I call this R1 and R2, I'm really performing the row operation, interchanging R1 and R2. So all that is doing is rewriting the rows in a different order, which means basically rewriting the equations in the system in a different order. And there we have it. Okay, so the next hurdle is I want to get a 0 here. And we get that by performing row operations. Remember that with the elimination method, our goal was to eliminate a variable by multiplying one or both equations, or in this case, rows, by a number, and then adding them to get rid of said variable. So here we're kind of controlling the situation. We're saying, okay, now that I have the 1 in the first row, I'm going to take negative 2 times the first row, and I'm going to add it to the second row, and that is going to become my new row 2. So here is how that plays out. Negative 2 row 1 is the row of numbers negative 2, negative 14, followed by an augment, and then negative 104. Row 2 is 2, followed by negative 3, followed by 2. If we add those together, we have 0, negative 17, and negative 102. So that's going to be my new row 2. Now I'm replacing row 2 with that because my row 1 is the way I want it right now. I have that 1 where I want it. I don't want to lose that. So the new matrix is 1, 7, 52, 0, negative 17, negative 102. Now we're only one step away from having this almost solved. So remember that the next step is that I want this to be a 1. The simplest way to do that is to divide the row by 17 or multiply the row by negative 1 over 17 is the more formal way to do that. So again, noticing that this is R1 and R2, what we're doing is taking negative 1/17 R2 and making that the new R2. So here's what we have. 1, 7, 52, 0. Now negative 117 times negative 17 is 1. Negative 117 times 102 is 6. So the Gaussian part of our solution is over with. Now let's translate these back into equations. We have x plus 7y equals 52 and y equals 6. So from here, we'll just back substitute the value of y into the first equation to find x. X plus 7 times 6 equals 52. X plus 42 equals 52, which means x equals 10. So there is a solution to our system. Again, we can write it as x equals 10, y equals 6, or in ordered pair form, 10, 6. And that is our solution using Gaussian elimination.